Hello everyone. In this video, we are going to explore a new feature of LuBan, Voronoi wireframe. Let's open LuBan and select an STL to start with. I'm going to load a CAD model. The Voronoi wireframe is added in an existing function, wireframe, which is under mesh LuBan and method wireframe. It is a new option under this method. If you are familiar with wireframe, or if you have used it before, you will know that it has a 2D version and a 3D version. The control that we added to accommodate the new feature Voronoi is the type. Previously, there is no type selection, or it is default to axial. You can change the number of wireframe layers in X, Y, Z direction, parallel to X and Y and Z axis. So it is an axial option. The second option is edge. You can choose to show the edge of the wireframe. There is an important parameter when the type option is not axial. If it is edge or Voronoi, then you can set the low poly setting to choose how much to simplify the original model. When you call this function for the first time, the low poly setting is automatically determined by LuBan algorithm, so that it can render the wireframe quickly. Therefore, you can see the low poly setting is a very low ratio. I can increase the ratio to 2% of the original mesh density, and then it looks pretty much like the CAD. Okay. When you set to Voronoi, and this is the Voronoi pattern you are going to get, but this is 2D only. And when you click Save Model, you are going to get a 2D, this is not 3D, 2D output of the pattern you see on screen. And let's go to the export folder. In the export folder, there is a DXF file, SHP file, which is native to LuBan, and SVG file. DXF and SVG can be used on any laser cutting software as input, so you can laser cut this pattern. And of course, if you have used this before, you know that you can turn on base-like socket and generate the model again. This will give you a base. Okay, let me reduce this to 30 so we can see this more clearly. Wait a second. Socket width. Okay, socket width set to 100. Okay, this is the width of the socket. Imagine that you will cut this from a transparent acrylic sheet. You can plug in this part into a base light and illuminate the pattern. Okay. This is all for 2D. For 3D, you can change the size of the model, obviously. You can set different low polygon simplification ratio. And you can also set the wire thickness. In 3D, there is a thickness setting for you to tune the pattern. Currently, I think the thickness is a bit too big for the size. So we can set it to 2, hit the Enter key to update display. Okay. Alternatively, you can increase the model size. For example, if I increase the Z dimension to 150, and the wire will appear to be thinner. The wire thickness didn't change, but the model is enlarged. Let's set it to 3. The model is bigger. And if we zoom in, you will see some gap. Okay, for instance, these gaps, you see the small gaps. This is only a rendering issue. When you click Save Model, the actual STL model will be generated, which does not have these gaps. But it takes quite a long time to generate the model. There is an algorithm for converting the previewed display to an STL model, and this takes some time, so I'll just let it compute. One more thing, if the width, if the wire thickness is set too small, for instance, you can set it to 0.1 or 0.2. If it is set too small, then the generated STL model may have incomplete wire or wireframe, or it may not even have any wireframe. This is because of the resolution that is below certain threshold dictated in the algorithm. If it is below certain threshold, the algorithm won't be able to generate wireframe. So the wire thickness, you have to set the thickness so that it is at least clearly visible on the preview in order to generate a valid Voronoi wireframe. It is still calculating. I tested this before. For this model, it might take 3 to 5 minutes to calculate. And it has nothing to do with the model size. Whether the model is very big or very small, it's going to take the same amount of time. When the calculation is done, I'm going to change the type to the second option, edge, so that you can see where it is coming from. Still calculating. Okay, it's done. That is the wireframe generated. The bottom is a bit nasty because that's the you will see that that's what it looks like in the original mesh. If we turn this option to edge, the edge is the original edge in the model, and it shows some clearly unreasonable triangulation on the bottom. So I have exited the LuBan mode and turn on the edge. That's what you see. When you are faced with such a surface, you might have an option to cut it off. For instance, I'll cut off the base. I will move the cutting plane to somewhere at the bottom, and I plan to cut it off, setting the close cut to no, regional cut to no, and then I will cut it, put it on the desktop, and I will close the current window, then open the part that is cut. It is the second part. In this model, it is a cut model. It is a hollow. This model is an unclosed model. Okay, you can see inside. It is unclosed. The wireframe function works equally well on such an unclosed model. I'll increase the model size to 200, and then the low poly count, I'll set it to 0.022%. As you can see, the bottom face is open. Okay, you can set to Voronoi. Similarly, the bottom face is open. So this is also a valid mesh. The default is axial, and the bottom will be open, 2D and 3D. Okay. That is all. I hope you enjoy this function. The Voronoi pattern usually generates a very beautiful, aesthetically beautiful mesh so that you can 3D print. Thank you for your attention.